Which of the following is the correct setup to eliminate the x's from the system? So in order to eliminate the x's, we need opposite coefficients. So if we're trying to get rid of x, we can multiply the first equation by 7 and the second equation by -4. We're switching the coefficients and we need one negative in there. So we get 28x plus 35y equals 42 and negative 28x plus 32y equals negative 36, which matches option C. In number 2, is 7 -2 a solution to the equation? So we're going to take 7, we're going to substitute in for the x's, we're going to take -2 and substitute in for the y's. So when we do that, our first equation, we have 2 times 7 minus or plus -2 equals 12. 2 times 7 is 14, minus 2 gets us 12. So this equation works. We're going to try the second equation, -5 times 7 minus -2 equals 33. -33. So -5 times 7 is -35, plus 2 equals -33, which is the number we wanted to equal. So because both equations come out as true and we get the same number on both sides, yes, this is a solution. In number 3, we want to write an equation of a system of equations to represent the segments. So in the first segment, our whole length is x, so we're going to equal x, and we're going to add the parts, 4y plus 7. In the second part, our whole length is 18. When we combine like terms, 2y plus y is 3y, and x plus 2x is 3x. So the two equations that match them would be D. In number 4 and 5, we want to determine the solution to the system of equations. So we are looking for where are those lines intersecting. So number 4, that intersects at -2, 4. And in number 5, it intersects at 4, -4. In number 6, in what row represents the solution? So remember, when we're solving by a table, the first equation is represented by the first 2 rows. The second equation is represented by the third row. So we are trying to figure out in what row we are equal to -6. So if we look, here's -6, so that would be row B. In number 7, we want to solve by graphing calculator and round our answer to the nearest hundredth. So we're going to take each equation and type these into y1 and y2 in our calculator. So y1 is going to be 5x plus 7, and y2 is going to be 2/3 x plus 1. So in our calculator, we go to y equals, and we're going to type in the equations we have. So the first equation is -5x plus 7. And the second equation is parenthesis 2 divided by 3x plus 1. Then to see the picture, we're going to hit graph, and we're going to draw a sketch of that. So we have one line coming down from left to right and one line going up from left to right. See our intersection point. We're going to have the calculator find that for us. So to find the intersection point, we hit second trace, the number 5 for the option that says intersect. Then we hit enter 3 times where it says intersection down here, and we can round. So that's going to be 1.06 and 1.71. So 1.06 comma 1.71. We also label that on the graph. In number 8, solve the following system of equations by substitution. So in substitution, we need a variable by itself. So we have y equals. So we are going to box what y equals and put it in for y in the second equation. We get 2x minus parentheses x minus 19 equals 27. When we distribute the negative, 2x minus x plus 19 equals 27. When We combine our x's, we get x plus 19 equals 27. We can subtract 19 from both sides, so we get x equals 8. Then we need to substitute back into one of the equations to find y. So I'm going to take x and put it in the first equation. So y equals 8 minus 19. So y is going to be negative 11. So our ordered pair would be 8 comma negative 11. In number 9, in order to solve by substitution, we need to have a variable by itself. We need x equals or y equals. So we don't have that yet. So we are going to subtract 3y from both sides. X equals 20 minus 3y. So we can box what x is equal to, and we can put it in for x in the first equation. Negative 5 times 20 minus 3y plus 2y equals 2. We can distribute the negative 5, so negative 100 plus 15y plus 2y equals 2. We combine our y's, we get 17y minus 100 equals 2. We can add 100 to both sides. 17y is equal to 102. When we divide both sides by 17, we get that y equals 6. So now we can take 6 and substitute. I'm going to substitute this time into the second equation. So x plus 3 times 6 equals 20. We get x plus 18 equals 20. We can subtract 18 on both sides, so x equals 2. So our ordered pair here would be 2, 6. Now we're going to solve by elimination. So in number 10, nothing eliminates right now, but we see that the x's have different signs. So I'm going to multiply the first equation by 7 and the second equation by 3. So when we do that, we get 21x minus 28y is equal to negative 476. We multiply by 3, negative 21x minus 15y is equal to 132. When we add straight down, x's. So when we add straight down, we get negative 43y is equal to negative 344. We divide by negative 43, we get y is 8. So now we can substitute 8 back in. So I'm going to use the first equation. 3x minus 4 times 8 equals negative 68. So we get 3x minus 32 equals negative 68. We can add 32 on both sides. So we get 3x equals negative 36. When we divide by 3, x is negative 12. So our ordered pair here would be negative 12, 8. In number 11, in order to do elimination, we need the variables on the same side. So right now, the 4y needs to move. So I'm going to subtract 4y to both sides. We get negative 3x plus 2y equals negative 5. And 6x minus 4y equals negative 10. To get rid of one of the variables, I can multiply my first equation by 2. So when we do that, negative 6x plus 4y equals negative 10. 6x minus 4y equals negative 10. So we add straight down. Everything is going to cancel out. So we're left with 0 equals 0, which means that this is infinitely many solutions. So in 12, let's look at our special cases, even though we just did a special case. So in number 12, we can solve this by substitution. So I'm going to put 3y minus 7 in for x. 2 times 3y minus 7 minus 6y equals 19. 6x minus 14 minus 6y equals 19. We combine the y's. We're left with negative 14 equals 19, which is not true. So this is a no solution. If we were to graph this, it would look like parallel lines. In number 13, to eliminate a variable, we can multiply the second equation by -3. We get 9x plus 12y equals 60, and -9x minus 12y equals -60. We add our equations straight down. The x's cancel, the y's cancel, and the numbers. We get 0 equals 0, which again is infinitely many solutions. And if we were to graph this, it would just look like one line, so it would be an overlapping line. In number 14, John has a total of 57 coins in his piggy bank. John found that he has a total of $10.35. The piggy bank only contains dimes and quarters. How many of each coin does he have? So our two coins here, we have dimes and we have quarters. We know there are a total of 57 coins, so D plus Q equals 57. And we know he has a total of $10.35. So a dime is 10 cents, so 0.10 D. Quarter is 25, so 0.25 Q equals $10.35. So now we can solve using elimination. So I'm going to multiply the first equation by negative 0.10. So negative 0.10 D minus 0.10 Q is equal to negative 5.70. Our second equation is 0.10 D plus 0.25 Q equals $10.35. When we add our equations straight down, the D's are going to cancel out. We're left with 0.15 Q is equal to 465. When we divide by 0.15, we get that Q is 31. So we can substitute 31 back in for Q. D plus 31 equals 57. We can subtract 31 from both sides. D is equal to 26. So the ordered pair here is going to be 26, 31. So John has 26 dimes and 31 quarters. In number 15, the basketball team is ordering pizzas for the end of the year party. They order a total of 7 pizzas. Cheese pizzas cost $9 and pepperoni pizzas cost $12.50. How much if the team spent $73.50, how many of each pizza did they order? So the two types of pizzas they got were cheese and pepperoni. So we're going to say C is equal to cheese pizza and P is pepperoni pizza. So we know together they got 7 pizzas, so C plus P equals 7. They spent a total of $37.50. We need to include the cost of each item. So cheese pizzas are $9 and pepperoni pizzas are $12.50. So we have 9C plus $12.50P equals $73.50. So in order to solve, we can multiply by -9. We get -9C minus 9P equals -63. 9C plus 1250P is equal to 7350. So when we add straight down, the P's cancel out, C's cancel out, and we're left with 3.50P equals 1050. We divide by 350, P is 3. So we can take our value of 3 and put it in for P. So C plus 3 equals 7. We can subtract 3 from both sides. C equals 4. So our ordered pair is 4, 3. which means that they ordered 4 cheese pizzas and 3 pepperoni. In number 16, the sum of two numbers is 40. The large number is 5 less than twice the small number. What are the two numbers? So our variables here are going to be the large number and the small number. So in the first one, we have the sum of two numbers is, which equals 40. So L plus S equals 40. Then we have the large number is 5 less than twice the small number. So twice the small number is 2S minus 5. So to solve for S, we can box what L is equal to, and we can substitute for L in the first equation. So we have 2S minus 5 plus S equals 40. We have 2S minus 5 plus S equals 40. We can combine the S's. 3S minus 5 equals 40. We can add 5 to both sides. 3S equals 45. We can divide by 3, so S equals 15. And then we're going to take our S value and substitute in. So L plus 15 equals 40. We can subtract 15 from both sides, so L equals 25. So our ordered pair is going to be 25 comma 15. So the large number is 25 and small number is 15.